Hey, welcome back. We're looking at lesson 3 today, systems of equations. And there's 3 ways we looked at doing this. One was graphing, which we're not going to look at today. We're going to focus on the algebraic way of solving a system, which is 2 methods, substitution and elimination. First of all, substitution. One of the equations has to be solved for either x or y. If you look at example number 1, the second equation is solved for y. So we can use substitution if this is the case. I'm going to go to equation number 1. So wherever I see a y, I'm going to substitute in that algebraic expression, negative 2x plus 1. So I'm going to go to my top equation. And I'm going to substitute this algebraic expression right here in for that y. So it's going to be 3 times negative 2x plus 1 equals negative 9. And then at this point, now we have an equation we can solve for x. So distribute your 3. I can combine my x's to get negative 4x. And solve for x, we're going to have to subtract 3 first. And then divide by negative 4. So we end up with x equals 3. So remember, when we are solving system, we were trying to find a point that they have in common. In other words, we're trying to find the intersecting point. So we have half of the intersecting point for this system. We got the x-coordinate. Now we need to find out what that y-coordinate is. So if you know x is 3, we will go to one of the equations, and it looks like to me that the second equation is probably going to be the easiest to solve for y. So let's plug in negative 3 for the x. And simplify this, so we'll get a positive 6 plus 1, y equals 7. So we'll end up with, whoops, what was my mistake, guys? Right there. So this would end up as negative 6 plus 1, negative 5. Okay, substitution. All right, elimination. When we used elimination, we wanted the x's to eliminate when we add the 2 equations, or the y's to eliminate when you add the 2 equations. If you look at example 2, and we add these up, my x's are not going to eliminate, and then the y's are not going to eliminate. So if that's the case, sometimes you may have to multiply just one of your equations by something, or you might have to multiply both. Okay, to figure that out, look at your coefficients of your x's, look at your coefficients of your y's. In order for these to eliminate, either the x's or the y's, the coefficients have to be opposites of each other. So if you look at your x coefficients, one's 6 and one's 12. Well, if this one's 12, I can make this negative 12 by multiplying by what? Yep, negative 2. So if I take my top equation times negative 2, we're going to multiply everything by negative 2. So that would be my top equation. Bottom equation, we're just going to leave that one alone, because now if you notice, the x's are opposites. So now when we add these up, my x's eliminate. Solve for y, all you got to do is divide by negative 11. So y is equal to positive 2. So again, we're looking for an intersecting point. We have half of that intersecting point, the y-coordinate. So to find the x, go to either equation. It doesn't matter the top one or the bottom one. I'm going to use the top one. Looks a little bit easier to use to me. And then plug in 2 for the y value. So plus 3 times 2 equals 0. So we'll end up with 6x plus 6 equals 0. Subtract 6. Divide by 6. And we'll end up with x equals -1. So there is your x coordinate. There's our intersecting point. Okay, so sometimes you only need to multiply one of your equations so that you get the x's or the y's to cancel. Example 3. Okay, look at your coefficients. Those are not opposites. These are not opposites. So we need to either multiply one or both. If you look at your x coordinates or your x coefficients, 1's 7, 1's 8. You need to find the smallest number that goes in, or they both go into. It's called the least common multiple. Or you could do it with the y. Since we got the x's to eliminate over here with example 2, let's get the y's to eliminate. So y coefficients, 3 and 7. Smallest number that both of these go into would be 21. Remember, one's got to be positive and one's got to be negative. So to get 21, I'm going to have to multiply by 3 on the top. And then the bottom, if I want this to be positive 21, I want this one to be negative 21. So I want to multiply by -7. So multiply everything on top by 3. So there's your top equation times 3. And then the bottom equation, multiply everything by -7. Oops. And now we can add these up and my y's eliminate. So 21 plus -56. So -35x. 21 plus 14 is 35. Divide by -35. And we end up with x equal -1. So we got half of our answer here. We got the x coordinate of that intersecting point. Find y. You can go to either the top equation or the bottom. I'm just going to use the top one. I'm going to replace or substitute -1 in for x. And then solve this equation for y. So I'm going to have to add 7. And then divide by 7. So now we've got our intersecting point of those two lines, and we did it all algebraically instead of graphically. Okay, so algebraic ways to solve a system: substitution or elimination. All right, you guys are ready for the worksheet.